Hello, everybody, and welcome to this episode of the Ampere Developer Impact. Today, I have the great pleasure of being joined by Antoine Toulmé, Principal Product Manager for Splunk, a Cisco company, and a core contributor to the Open Telemetry Collector project. Welcome, Antoine.
Thank you. Great to be here.
The reason we've invited you on, obviously, is because of your involvement in Open Telemetry. And we've been doing some work with Open Telemetry, and Ampere has been doing some work with Open Telemetry. So can you, to get us started, just give us an overview of what is Open Telemetry and why should people care about it?
Absolutely. Open Telemetry is a CNCF project, a Cloud Native Computing Foundation, which is also the foundation that harbors the Kubernetes project. Open Telemetry is an open source project that spans different observability methods. It came about 2019 as the result of the Open Census and Open Tracing projects kind of coming together as the community realized that there was a lot of vendor lock-in around observability. Observability is all about understanding how your software is working at runtime by getting metrics, traces, logs, and now profiling. So we can understand how your software is behaving. We can do root cause analysis faster. We can understand some of the performance and some of the utilization of your software, hardware underneath. And Open Telemetry has been really a front runner in helping the ecosystem mature in a sense. So we're very, very lucky to be there. It's a very big project. It has a wide-ranging set of skills that are required to participate. We have folks who are just working on the specification, which is kind of the heart of the project, really, to kind of coming together, agreeing on what we need to standardize, commoditize, make easier for folks to adopt. And then based off that, we have a developer experience that has been built around SDKs for instrumentation, for augmentation of existing runtimes, so that we can explore how to instrument existing calls to databases or queue systems to get traces from there, to extract metrics from there, which are going to help you better understand how your software is doing. And we also have a project called the Collector, which is middleware that allows you to either passively get signals, to batch them, to augment them, to also filter them or drop some of the data because we might have too much, and send that to backends that are supporting the Open Telemetry semantics, or also can do some level of scraping itself, can go and fetch the information by reading files to read logs, or scraping your host to get host metrics such as CPU, memory, these type of things. So This is a really big project. It's the second project in the CNCF behind Kubernetes in terms of adoption, number of contributors, and activity.
So in short, from an application developer operations team perspective, you have sets of agents that can instrument applications. And then from an observability platform vendor perspective, you have a set of interfaces that you implement on top of your observability platform that kind of conform to the Open Telemetry standard. Is that correct?
That is, yes, exactly right. And it's very helpful for everybody involved.
Yes. So how do you avoid falling into the XKCD 927? For those who don't know it, the idea that, if there are 14 standards, this is ridiculous. You need to create a single standard to unify them all, and then you end up with 15 standards. How do you avoid that problem in Open Telemetry?
So it takes a very long time. We have every single decision goes through several stages. First, we never kind of make a pronouncement that something is final on the first go. We actually have stages of adoption where first go with an experimental view into a particular metric or a semantic convention. We agonize over every name, the name of even the units that we're going to use. We come up with some really strong guidelines. I have to commend here all the folks that work on the specification. They are extremely talented, and they spend weeks on end really just deciphering the intent behind some of the folks coming to bring them new use cases, right? And we've had some really interesting use cases, such as the ability to standardize how we're going to talk about CI/CD type semantic conventions, which are kind of an uncharted territory, right? Just to give you an example that's a bit more out there, we've had some really good results with cloud provider vendors such as Amazon, Microsoft, and all, who have come together and have contributed time to agree on what those semantic conventions should be. And what they do is they actually build and package the semantic conventions as an artifact. It can be imported by all the other SDKs so that they can easily adopt those conventions over time. We have breaking changes. We have a whole set of ecosystem movements that allow us to have a pace of adoption that is kind of going to be similar across all languages.
Yep.
I would point out that really what's happening is we're using the rough consensus approach. It's an IETF approach to make sure that we don't just go with the first idea or whoever is the loudest in the room, but we keep the conversation going long enough, and we never really settle until we have had everybody kind of participating into the conversation.
So the rough consensus is the standard, and then the second part of that I love is rough consensus and running code.
That's right.
So then Open Telemetry is the running code that implements that consensus, correct?
Yes, and I think there's a feedback mechanism here that feeds back into the specification that is really important. That eventually, 3-6 months after making an enactment from the semantic convention standpoint, there's always going to be a little bit of a feedback coming back from actual real users who are starting to understand the value of having these type of artifacts in place and in this type of conventions, and always come back with a little bit of a tweak or some discussion there.
I love it. Love it. So we are here at the Ampere Developer Impact. So I guess we're going to have to talk a little bit about, your story of on ARM64. So I know you've been involved in getting Open Telemetry supported on ARM64 for quite some time. Can you walk us through the last 2 years? Like, what is the Open Telemetry on ARM64 story?
So we were very, very lucky to meet one of your members at KubeCon, who was just offering that we would be able to maybe get some hardware from Ampere to kind of get a little bit of a bootstrap effort started, right? So we worked first with a physical appliance. I think it was with one of your employees that we worked with a Mount Collins server. That Mount Collins was installed in one of our data centers so that we could actually use it for CI/CD purposes. And he gave us a leg up to understand how to best instrument the code, how to best run it in that setup. It was an interesting experience on its own because it's really powerful hardware, right? You would get some very different setup from this. We actually had some early feedback from customers that some of the Open Telemetry instrumentations were not working well on ARM because there are so many cores, right? So you go from 4 cores to 100, 200, 256 sometimes. We've had some interesting performance limitations. We went about to fix them by using this hardware. We also use that hardware to test our Node.js or Java, I believe, or Python, and all those different SDKs. So we were able to kind of get a feel for what it felt like on ARM. And frankly, the ecosystem for ARM, we have had no problem that much for Open Telemetry itself in terms of adoption. We're seeing that it's pretty mature in terms of code. The type of issues we had were more about testing the third-party applications and libraries. So we would see, for example, Docker images that claim they are ARM compliant. And when you actually run them in a CI/CD environment and you actually mean to run them on an ARM server, you realize that actually they just package the AMD code and they just make that run as if it was ARM. So that was a bit of a letdown. We've had to kind of make sure we're able to kind of control for that. But I have to say, like in the last 2 years, we're seeing a huge improvement in terms of support for ARM.
So going back to like 2023, Open Telemetry did not have any support for ARM. Is that correct?
That's right.
Okay.
That's right. We had maybe some binaries, but we had no idea whether it would work as much. In terms of performance, as I mentioned, we started to run into performance issues.
And so then you went from having the technical enablement, being able to do that on ARM hardware on-prem. How did you translate that to getting CI for the open source project up to a par with x86?
We were very lucky again that we are part of the Cloud Native Computing Foundation, and Ampere has been very graceful and gave us access to Ampere servers, which are being hosted and made available to the CNCF. We worked there with Alex Ellis and Actuated, who helped us set up GitHub Action runners that were using this hardware that really gave us a way for us to really interface with that without having to contribute our own CI/CD infrastructure, which is extremely wasteful in terms of time, especially as GitHub Actions runner are quite used by our projects. We have a huge build system. We were able to get this off the ground. We ran into treacherous situations where our CI/CD, as I mentioned, is extremely taxing. So while it worked really well for some portions of the projects, we had others that were just exploding in terms of complexity and also frequency. So we had to scale down a little bit some of that involvement, but we've been very good at leveraging this, and Alex was very supportive of this effort. We really got very far with this. So with Actuated, we were able to kind of get to a point where we opened this to the community. We're able to show this to the Open Telemetry project as a whole. And we started to have the conversation about what it would look like for us to support this as a complete solution.
And so what's the level of support today?
So today, we have defined different levels of support inside Open Telemetry just to set expectations right. And if you would see here, we have an open issue right now to move to what we call Tier 1. Now, right now, we're in Tier 2. What that means is that we know that it works. We know that we will make fixes for it, but we don't consider a change that would break ARM64 support enough to make an emergency release or to stop the release process. We only have, and this is a very high tailored support for this, only Linux AMD 64 is Tier 1 at this time, right? You can see some of that information in the platform support link here. We have a number of other platforms that we're supporting in Tier 3, which is more or less best effort, right? So we can talk to it and we compile to it, but we don't know if it works well. Tier 1, if we're able to move from Tier 2 to Tier 1, will give us a way to run on every pull request. So any change to the repository should be tested for ARM. And we would also have performance tests that would be run every time we make a change to our collector. So that would give us a lot more in terms of fidelity, and we would be able to really recommend to run this in production at large scale, which is the ultimate goal for us.
Right. And I believe you were also using Ampere instances on OCI for your CI/CD after moving away from the Actuated project. Is that correct?
That is correct. So we are able right now to run our tests, and I can show you that actually. We are able to run a number of tests already on this type of runners, and that gives us a good level of understanding in terms of unit testing and things like this. We have a good cache with this type of runner, so we're very effective and supple when it comes to this, where we can really run those fast. We want to do more. We want to run more integration type tests, performance tests, as I mentioned, but this is a good start for us.
Okay.
We'll do even more moving forward.
And what are you using right now for the ARM runners on GitHub?
Well, as you can see here, we're using ARM runners, which are offered by GitHub itself, and we also run on macOS just to make sure we have a different type of test that we have good coverage. That said, we want even more moving forward.
Yes, yeah, and we would love to see that happen.
Mm-hmm.
Okay, so can I ask? Obviously, we've come to ARM64 being supported as a Tier 2 platform by Open Telemetry and aiming for Tier 1.
Yes.
Have you seen any usage? Do you have any end users who are using OTel, Open Telemetry, on ARM64 regularly for production workloads? And what's the feedback been?
So we definitely have seen that. We are definitely using that internally. I can't comment too much, but this is something that we have been leveraging heavily for production workloads for a while. We're very happy about the results. We see, the cost issue, the performance on ARM is much higher than what we would get with the legacy type servers on x86. We were very happy with this type of development. We also see that as a big uptake for our customers. We have right now for our own customer base, published Docker images that support both Linux AMD 64, but also all the ARM64 variants. We are seeing a great uptake in terms of ARM64 downloads.
In short, you're seeing a lot of uptake, and in particularly for cost benefit, price performance benefit, you're seeing a lot of take up of the ARM64.
I mean, I can say without a doubt that in general we're seeing. I'm a convert, right? I really like ARM64. I see that in terms of performance, we see a cost reduction that's like 15% across the board. Just adopting same technology, same code, right? Moving from x86 to ARM64.
And that's just by changing the instance type?
Yes, absolutely.
Do you find that you're using fewer instances because of using single-threaded cores, or is that not something that you track as much?
Yes, we are using fewer instances, and we are seeing better memory allocation as well.
Okay.
I expect that we'll see even more of that. Actually, one thing that is popping up in our CI/CD is that we see that ARM64, especially when we run with the collector is written in Golang, right? Which is just one such instantiation of an ARM64 program. Golang for ARM64 is catching every single synchronous issues, like anything related to locks, something like this. So I believe that what's happening under the hood is that the lock implementation, either for Golang or even down at the level of the processor instructions related to ARM64, is slightly different from what you see with AMD 64. But what we see is, I think, is that those locks are much more finite and atomic, and we sometimes have issues that we only pick up on ARM64 CI that don't show up on the AMD 64 CI.
So is that a good thing in terms of like you're identifying issues that are there and giving you the opportunity to fix them, or is it a bad thing in that you're seeing problems on one platform that don't exist on the other?
Well, it's kind of both, but it's a good thing for the most part, because what it's showing is that on this platform, we have much finer locks, and before we might be able to get away with just having a sleep in a code or something like that, but with ARM64, those locks are being released so much early that we are able to catch issues that were kind of silent in AMD64.
I see. So in short, you're catching in your CI and testing race conditions that might otherwise have gotten through and only been found by customers in production.
That's right. And paradoxically, this helps us with debugging things for Windows, because Windows also has locks issues, and we are seeing that consistently across the board, that we keep on having those issues.
Okay. Do you want to share the story behind your T-shirt while we're here? I noticed you've got.
I would love to. This is a T-shirt that was gifted to me by Steve Flanders. Steve has delivered a book called Mastering OTel and Oli. It's available, and I was lucky enough to review it for him. If you were to look for a material to get started with Open Telemetry, I can recommend that book wholeheartedly. This is a great way for you to kind of understand the not just the technical aspect of it, but also why observability can make your organization a better organization that's more flexible and can kind of think in terms of SLAs, KPIs that observability allow you to have at the level of operations.
Okay. Well, thank you for joining me today, Antoine. Everybody, I recommend that you check out Open Telemetry, and in general, I think improving observability and improving the instrumentation of applications in the cloud is really fundamental to taking advantage of the promise of cloud-native computing. So thank you very much for joining me today. And thank you all for watching until now, and we will see you at a future episode of the Ampere Developer Impact.
Thank you.